Hello everybody and welcome to area of a triangle. Well, what we know already is the area of a rectangle is length times width. Okay, so for example here on my fabulous Geo board, I've got the area of a rectangle. And it looks like you want to count the spaces. 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6. So it's a 5 by 6 rectangle. So we could actually count, and it's got 5 rows of 6 squares. So that makes 30. The area of this rectangle is 30. But we're talking about a triangle. And so what happens with a triangle is, with a triangle, what we do is we do half of it. Now why? Well, look, it's got the same base of 6, the same height of 5, but it's got this diagonal, and that is what makes up the triangle, the green, and it is exactly half of the area of the original rectangle. So it's 6 times 5, but you want only half of it. So instead of 30, it's 15. Now the cool part is, how does the base or the height work? So the base right now appears to be here and the height appears to be here. Now reality is, couldn't I say instead that this is the base and this is the height? The cool part is I can move that top point to any of these along here, and this triangle here will still have an area of 15. Well, how is that? You could think of it in a couple ways. If I was to actually make a line right down here, this height here is 1, 2, 3, 4, 5. So I could break this into 2 right triangles. So if we talked about this first right triangle, it is 5 by 3. But again, it's half of it. So what's half of 5 times 3? Well, 5 times 3 is, so this side is 7.5 because it was half of 15. And then this side is half of 5 by 4. So 5 by 4 is 20, and half of 20 is 10. Uh-oh, what did Miss Nackman do wrong here? Because this is making 17.5. Oh, it's not 4. It is also 3. Again, sometimes people mess up and they count the pegs, and you actually want to count the spaces. So it's actually 3 by 5. So this one is also 7.5. And what is 7.5 plus 7.5? It is 15, which brings us back to the length was 6, the height was 5. So half of it was 15. And the base is in fact 6. And the height, though, is where it meets the base at a right angle, and that is 5. So no need to break it into 2 separate triangles with the height of 5. Instead, I can just call it 1 triangle with the base 6 and the height 5. Okay? So an important thing to write down. So an important thing to write down is that the base and the height meet at a right angle. This was the first triangle we did where we had a base of 6 and a height of 5, and we said 6 times 5 is 30, but we said it's not the full rectangle. Instead, it's just half of it. Okay? The second one we did was not a right triangle. What you want is still, this is the base at this vision and how we're looking at it, but instead this here is the height. So you need to have that information, otherwise you can't find the base and the height. The last example is a really tricky one. It's an obtuse triangle, and it gets really confusing for people. So if I take this green and I actually stretch it out to here, and I make it extend beyond what we have already as our square, this in fact still has a base of 6, and its height is still 5. So this still has the area of half of 6 times 5. So it still has an area of 15. Now that's really confusing for people to see, so we are going to make sure that that's true via a different route. Okay? Alright, so what I did was I took that rubber band that was here and I stretched it out to here to make it a bigger rectangle, because I think it's easier for us to see it inside this. But it still has the same base of 1, 2, 3, 4, 5, 6. It still has the same height of 1, 2, 3, 4, 5. So instead, how it's drawn is this is your base, but the odd part is if you extend that base and the highest point of the triangle, you extend it down, where they meet, that is where the right triangle is. So this distance here is your height. So let's think about this and see if it does actually have an area of 15 again. So I think the easiest way to solve this is to figure out the area of the whole rectangle. So the whole rectangle now is 1, 2, 3, 4, 5, 6, 7, 8. So I like to do area and I like to write rectangle to abbreviate. The area of the rectangle is 8 by 1, 2, 3, 4, 5 still. So 8 by 5, which is 40. That's the area of the rectangle. And now let's figure out the area of this triangle up here. Well, this triangle right here, I would say has maybe a base and a height, or you could do a base and a height. Half of 5 by 8. And if I'm going to figure out half of 5 by 8, I'm going to actually do half of 8 is 4, and 4 times 5 is 20. Or I could do 5 times 8 is 40, and half of 40 is 20. Let's figure out the area of this other skinny triangle. This other little triangle here, which is another right triangle, is 2 by 5. So its area is half of 2 by 5. Well, 2 times 5 is 10. Half of 10 is 5. Or the half times 2 multiplies to 1 and times 5 goes back to 5. So I basically have this whole rectangle, which is 40, and I'm going to subtract this triangle, which is 20. So now I'm down to the left with 20, and I'm going to subtract the 5 that's here. So 20 minus 5 leaves me with the area of this is back to a 15. And isn't that the same we had for the area of these other triangles here? So just proved how this one is also an area of 15. So what's the main important thing here is in order to find the area of a triangle, the easiest is definitely a right triangle. You just do the base times the height, right? Divide by 2. Or you can say multiply by half because it's a half a rectangle. If you have something where you're just given the base and the height is not one of the sides of the triangle because it's not a right triangle, then you want to just figure out where the base and the height meet at a right angle and use those. This length and this length are unimportant in finding the area. You would only need those lengths if you're trying to find what class? Perimeter! Very good. Okay, and again, you need the base and you need the height. And this is an oddball problem because the height isn't even within the problem, within the shape. It's an exterior idea of the highest point. How far is it from the lowest point? It's not even the lowest point. It's the extension of where the base would be. Okay, so area of a triangle. Thanks a bunch. What?